So this video will show you how to complete those z-score problems using your calculator. With the first example, we had this, we were asked for the percent of drives that travel at most 290 yards. Now the steps involved with solving this problem are the same. You'll still state the problem in terms of a variable. You'll still draw a picture of the distribution and shade the area. And then in step 3, that's where the difference occurs. Instead of standardizing the score and then using table A, you'll use a calculator function called normal CDF. So here's how it works. So we have our example. The first step, of course, is to restate the problem in terms of a variable x. So we want the proportion of x scores that are less than or equal to 290. And so we want kind of a shaded picture here. We're looking for that shaded region. And so in order to find that, we're going to use the normal CDF function. And we'll show you how that works in just a second. But before we begin, there are 4 values that you enter into the normal CDF function. There's a lower boundary, an upper boundary, mean, and standard deviation. Now because this is a left tail distribution, the lower boundary here is, well, it's negative infinity. Up to an upper boundary of 290, the mean was given as 304, and the standard deviation was also given as 8. And so now we can pull out the calculator and do some calculations.
To use the normal CDF feature on your TI-89, you'll go to the stat list editor, and then where it says F5 distr, that stands for distributions, we'll go down to normal CDF, choice number 4. I think I can safely say you're never going to use normal PDF in our course. It'll always be normal CDF. And then it will ask you for a lower value, upper value, mu, and sigma. Since we're asking for the percent of drives that are less than 290, we don't have a lower boundary. In fact, lower boundary is infinitely low. And so you can actually type in negative infinity by saying negative, and then the infinity button is green diamond catalog. So our lower boundary is negative infinity up to 290. The mean value again was 304, and the standard deviation was 8. Then tap enter once again, and it gives us a CDF value of 0.040059, and so on.
So notice when we use the calculator, we get 0.0059 and so on. And when we use table A, we had 0.0401. You'll notice there's a slight difference, but again, that slight difference is just due to rounding. The difference is negligible, it won't be a problem. So we conclude that about 4% of Phil Mickelson's drives travel at most 290 yards. Let's take a look at another example. What percent of drives are between 305 and 325 yards? Once again, we'll start the problem with the statement of the problem in terms of a variable x. Then we want to shade the distribution to show what the area of interest is. In this case, we're looking between 305 and 325. And then we'll use the normal CDF function.
To calculate the percent of drives between 305 and 325 yards, we'll again use normal CDF. But in this case, the lower value is 305. The upper value is 325. We still have the same mean and standard deviation. And so we get an area of 0.4459.
So if you remember, when we calculated this problem using the z-score method, using the table A, we first had to find the area to the left of 2.63, subtract the area to the left of 0.13 to give us that combined total area of 0.4440. Now, using your calculator makes this one step instead of 3 steps. And so we conclude about 45, let's say 45% of scores are between those two values. One last example, working in reverse. Now let's say we're dealing with these adult male heights, and we want to figure out the first quartile. In other words, we want to figure out what value gives us 25% of the distribution to the left of whatever certain score. So we know we're looking for the shaded, well, in this case, we actually know the shaded area. We know the shaded area is 0.25, and we want to find the value that gives us that shaded area. This is a new type of problem, and so we'll use a different function. The function is called the inverse norm, or inv-norm. Now there are 13 values to enter. First value is the shaded area on the left side of the distribution only, the mean, and standard deviation, which is given as 3.
To use the inverse norm feature on the T89, again, use the StatList editor and then go to F5, Distributions. Choice number 2 says inverse, and you see there's a triangle to the right. If you tap the right arrow button, you'll see the first choice is inverse normal. So we had an area of 0.25, mean was 69, and standard deviation was 3. And so that gives me 66.97, or approximately 67.
And so using the inverse norm function, we see that the first quartile of male heights is at about 67 inches. In other words, 25% of all males are 67 inches or shorter.